All right, good evening. Welcome to Trigonometry. We are going to take a look at test tube problem inventory, which means we're just going to kind of run through a bunch of these problems. So this is going to be problem 1A, and the instructions are graph y equals 4 tangent of 2x minus 1. We're going to note 5 points, including some asymptotes, an intercept, and a couple of two extra points here. So as we go through this thing, what we're going to do is, and I typically run these problems kind of the same way every time. So if I didn't have a tangent if I just had the parent function of a tangent, the points I would want to graph are negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. In radians, these are really easy angles. If I plug these guys into a calculator, at least for these three, I'm going to get nice answers out. Like tangent of pi over 4, tangent of 45 degrees is 1. Now, the negative pi over 2 and the positive pi over 2, those are my asymptotes. So plugging those numbers into the calculator is not going to give me a really nice number. It's going to give me an undefined in the calculator. So what I want to do is I need to adjust this. I need to find x's so that when x is this number, this whole argument here is actually a value that I'd be interested in. Okay, so the way I like to do this is to pretty much go down I just go down the list and go ahead and deal with it. You can do these in any order you like. Maybe you want to start with 0 because those typically are easier to solve. But whatever we're going to do, I'm just going to solve these in order. We're just going to go down the list. So I'm going to say, what does x have to be so that 2x minus 1 is equal to negative pi over 2? All right, that's what we have to figure out. So I'm going to go ahead and add 1 to both sides. We have 2x equals negative pi over 2 plus 1. I'm going to go ahead and get a common denominator here. So instead of plus 1, I'm going to say this is actually 2 over 2. So we have 2x equals negative pi plus 2 all over 2. And then I'm just going to get x by itself and then divide by 2. So we can say x equals negative pi plus 2 all over 4. All right. And I'm going to label that point A. Just going to put this off to the side here. You'll see why in a moment. Now, we're just going to go down the list here. We have 2x minus 1 is equal to negative pi over 4. Here we have 2x equals negative pi over 4 plus 1. And again, we're going to turn this into a common denominator. So I'm going to say this is going to be 2 over 2, or 4 over 4 rather. So we're going to say this is 2x equals negative pi plus 4 all over 4. And then what we're going to do is we're going to divide both sides by 2, and we're going to say this is going to be negative pi plus 4 all over 8. Okay, as I'm looking to do this, I'm going to erase my a for a moment here. I'll bring it back in a moment. One of the things that I'm interested in doing is I'm interested in making a pattern because that's one of the ways I'm going to check to see whether or not my numbers here are all correct. So I'm noticing that there's an 8 here. Can I do anything to this first piece here so that it's all over 8s rather than over 4s? I'm like, sure, this could multiply by 1. So we can say this is negative 2 pi plus 4 all over 8. My next point is negative 1 pi plus 4 all over 8. Okay, next thing, we're done with this part of it. We're going to say 2x minus 1 is equal to 0. Let's go ahead and solve. We have 2x equals 1, right? We just add 1 to both sides. And I'm going to go ahead and just solve this. And you can say, okay, this is going to be 2x equals, and I'm going to say, I would like to say that this is going to be, instead of 1, I'm going to say 1 is actually equal to 4 fourths. Okay, so this is 4 over 4. So I'm going to say we have 0 pi, that's a fancy way to write 0, plus 4, right, all over 4 here. And then we're going to divide by 2, and we could say that x is equal to 0 pi plus 4 all over 8. Okay, because I divided by 2 here. Okay, now you can start to see, like, hey, I think they're starting to see a pattern here, right? We have negative 2 pi plus 4 all over 8, negative pi plus 4 all over 8, 0 pi plus 4 all over 8. I'm going to guess that I think the next one is going to be 1 pi plus 4 all over 8, and the next after that is going to be 2 pi plus 4 all over 8. So that's my little guess to see what's going to happen, but I'm going to solve the rest of these guys. So we have 2x minus 1 is equal to pi over 4. Add 1 to both sides. We have 2x equals, and we're going to say pi over 4 plus 1. But it's really 4 over 4, right? So we could do that. So we have 2x equals pi, now that they have common denominators, plus 4 all over 4. And I divide by sides by 2, and we get x equals 1 pi, you can just say pi, plus 4 all over 8. And like that my prediction was right. So I'm pretty happy about the fact that I think I'm doing this correctly, right? These are always going to make a pattern. Then we have 2x minus 1 is equal to pi over 2. And we're just going to repeat these steps and say this is 2x is equal to pi over 2 plus 1, or 2 over 2, right? So we're going to say this is 2x equals pi plus 2 all over 2. Remember, we had 8s over here. So even though I'm going to divide by 2 and we're going to get 4s, I'd really like to do one more 2 in here just to preserve my pattern. So we're going to say we have 2x plus 4 all over 4 here. Okay. And when I divide, we're going to say we have 2x, 2 pi plus 4 all over 8. And that is my last point. Now I'm going to go ahead and label these A, B, C, D, E. So when I go to graph these points, I'm going to be able to say what's going to happen here. So we're going to say that this is going to be A is over here somewhere. Okay. And we can go a little bit further than that. Okay. We'll go ahead and make it kind of pretty as far as my drawing goes, or as pretty as we can. So we'll say, okay, here's my A, here's my B, here's C, here's D, here is E. You could use Roman numerals and go like, 1, 2, 3, 4, that would be fine. But point A, that's my asymptote, okay? Point E, that's also an asymptote. Point D is going to be when the value is a value of 1, and then point C is when it's 0. Now, last thing I have to do is I have to make sure that I scale my vertical axis when we have x is equal to pi plus 4 all over 8. That would make the whole argument equal to 0. Tangent of 0 is 0. So we're going to be here. But here I'm going to say this is going to be 4, and this is going to be negative 4. Okay? So I can go ahead and draw my graph in here. Now, when I'm grading these things, I look for a couple of things. I look for, did you have the right shifts in your points? I'm checking these guys over here. Are these correct? Okay. And they, are they correct, and will they reduce down to what they're supposed to be? I'm looking for, did you get the right shape of your graph? So far that leaves me like a 2, 4, 6, 8, 10 kind of idea for what I tend to grade with. Okay, so tangent, you have to remember tangent is negative pi over 2 to positive pi over 2. That's my period for tangent. Okay, we also have to have, if you're going to do that, you might want to know cotangent goes from 0 to pi, and the points that I would do for cotangent would be 0, pi over 4, pi over 2, 3 pi over 4, and finally pi. Just like I'm counting quarters, like the actual coin quarters. So we have 1 quarter, 2 quarter, 3 quarters, and 4 quarters to be like a dollar. Okay, and that's what I would do for cotangent. But for tangent, we go from negative pi over 2 to positive pi over 2, and that's how we go ahead and graph this. I'm going to say thank you very much for watching the video, and I will see you in the next one. All right, take care.